All right, so now we get to the idea of a household circuit where this is parallel. First key is it's parallel wiring for a household. So if you have to draw the house circuit, make sure it's in parallel because you want them all to get the whole voltage and calculating all the things. So step one, explain why the appliances are in parallel. Why would it be wired in parallel? So there's kind of two main reasons. One is each device gets each device gets full voltage. And then the second one is that you don't want one device being unplugged or going out to cause the other, so they can operate independently. Each device can operate independent. Calculate the current through the blender. So I jump over here and I see the blender. Again, remember the blender is the one that we know the resistance of. So this is the blender and the microwave. That one I know resistance and voltage. So it's going to be V equals I times R for this. 120 equals I times 8. And so I equals 4 amps for sorry, 30. I don't know where I got 8 from. That's definitely not 8. 30. 30. And so that will be 4 amps of current. So the next is to calculate the current of the microwave. But this one, we know the power rating. So we're going to have to use a different equation for that. We're going to use power equals voltage times current. We know that power rating of 1440 is that's going to equal the voltage, still 120 volts. But now we can find the current that way. And the current for the microwave comes out to be 12 amps of current. All right. So next question is if it's on a 15 amp fuse. A fuse is a little device that you put in there, and it's got a little filament in there that melts. So this little filament will melt at 15 amps of current. It heats up, and then it fire. Earlier, red, fire. Not fire at all. It melts. It just melts. You know what? Let's not do that. Let's just say that it melts. Oh, here we go. Melt. There's no fire. It actually is designed to prevent a fire. Fuses prevent fires. So anyway, so the fuse, will it blow? Well, if we look at each one, 4 amps plus 12 amps gives me 16 amps, and 16 is greater than 15 amp fuse. So yes, it melts. All right. So then we get to the purpose of the fuse. This is what I was talking about here. What's the purpose of the fuse? Is to melt when the current gets too high to prevent a fire. So melt when the current gets too high to prevent a fire. Right. So there we go. Keyword current, not voltage or power or anything else. It's when the current gets too high, and then that prevents it from catching fire later, other parts of the circuit. So if the blender is run for 5 minutes. Minutes. 5 times 60 is 300 seconds. Ooh, all right. We need to make sure we're in second. Calculate the power in watts. So for the blender, power is voltage times current. So it's 120 volts times that 4 amps of current. And that gives me 480 watts. So I didn't need the time for that one, but energy. There we go. Energy is power times time, and that needs to be in watts and seconds for joules. If it's in joules, so 480 times 300 gives me a big number because electricity is a lot of energy. 144,000 joules. So we use kilowatt hours. So let's look at the microwave for an entire month. If we use the microwave for 16 hours, oh good, we're already in hours, right? Kilowatt hours. So energy is just going to be the power times the time. But now we need to be in kilowatts. So I need to take that power of the microwave, right? Kilowatts is watt divided by 1,000. So I'm going to take that 1440 divided by 1,000, and I can see that it is 1.44 kilowatts. So I'll use that 1.44 kilowatts times 16 hours. All right. And that is only 23 kilowatt hours, despite the fact that it is a lot more energy than the joules from the blender. All right. And then the total cost, if it's 27 cents, again, a little bit cheaper than today's electricity, but 27 cents money is just the energy times the cost. So it would be that 23 kilowatt hours times the cost per kilowatt hour, 0.27. And that comes out to be about $6.22. All right. And that is question number 5.